the width of each subinterval. I forgot to turn on my next video. The width of each subinterval will be, of course, denoted by delta x. We know that from the approximations from the previous chapter. It will be 2 minus 0, b minus a over n. Okay, so this is 0, comma 2, which is nothing else but a comma b. The interval in general is a comma b. 2 minus 0, in our case, 2 minus 0. What does n represent? The number of subintervals. Number of subintervals, which is 2. So that's why the width for us in this simple example is 1. 1, 1. Good. We're going to look at two options. Option number 1, using the leftmost point. Number 2, using the rightmost point. And you can say, what is going on here? What are you really telling me? Okay. So again, I don't want to go back. I'm going to copy that graph again here. So we established that this is 1 unit, this is 0, this is 1, and this is 2. And I want to illustrate how I determine the area, the approximate, the area with the leftmost point. Okay, what does the leftmost point mean? It means base times the height, this area. Base times the height, this area. So I will say the area with the leftmost point with 2 subintervals is base of 1 times f of 0 plus base of 1 times f of 1. Can anyone tell us whether this result will be an overestimation or an underestimation of the actual exact area?
An underestimation.
Of course, look at how much I'm missing. Underestimate. Thank you. So this can stay outside because it's the same number, right? It's 1. F of 0. For our function, f of 0 is 1 plus f of 1 is 2. So the answer is 3. So using the leftmost point, I determined that an approximate underestimate of the area is 3. Okay. How do I do it with the rightmost point? I don't want to put it there because it would be difficult to see. Okay, now with the rightmost point. Base times height. Base times height. Because I can only calculate rectangles. So the area with the rightmost point and 2 subintervals is base times height, 1 times f of 1 plus base times height, 1 times f of 2. So this is f of 1, I know, is 1 plus 1, which is 2, and f of 2 was 4 plus 1, 5. So the answer is 7. Will this area with rightmost point and 2 subintervals, will it be an underestimate or an overestimate of the area?
An overestimate.
Very good, awesome. Because this area does not belong under the graph. This area is not below under the. It's not under the graph. It does, and this is above. So obviously it's an overestimate. So the true area should be somewhere between 7 and 3. I don't know what it is. So there are many other methods of estimating, but we are only looking at 2 to find the approximation, with the leftmost point and the rightmost point. We have others. Midpoint, we have the trapezoidal rule, we have Simpson's rule, but we only look at the simple ones here in this class. Just approximate with the left and the right. Now, will this ever be useful? Yes, because sometimes we will not be able to find for all functions. I'm going back here for a second. We were given this function, and we were very, very easily able to determine the antiderivative. But this is not always happening. So we may be given a function here, and we will never be able by hand to determine the antiderivative. And if I'm asked to find the cost between this and this, I can still come up with an estimate. Okay? Now, here's a question for you. What if I use 4 subintervals? Will the area be closer to the true exact area? If n is 4, will I get a better estimate? With 4 subintervals?
Yes.
Of course. What about 8? What about 16? What about 32? What about if n approaches infinity? You can say, how is that possible? Will I get a better and better estimate?
Yes.
Yes. What concept is that we looked at the entire semester so far?
The limit.
Yes! Limit as n approaches infinity. Yes. Yes, indeed. That's indeed the case. Okay. Okay, let's look at simple examples here. I am on page 402. 402. Let's approximate an area. Approximate the area under the graph of this over the interval this using 4 subintervals. 4 subintervals. Anything above 4, it's not an exercise in understanding. It's an exercise in endurance. So let's choose 1 and work on approximating. So let's choose 1, please. Anyone?
22.
22. Okay, so let's look at 22. 22. Good. So approximate g of x equals negative 0.02 x to the 4th plus 0.28 x cubed minus 0.3 x squared plus 20. So they're giving us 3 to 12, and they want us to use 4 subintervals and approximate the area under the graph. They're not telling us what. So it means it's our decision. Leftmost point, rightmost point, you choose. Okay, they're not specifying. Okay, so what would you like? Leftmost point, rightmost point?
Left.
Left. Okay, so we want to find the area with left and 4 subintervals. So n equals 4. So first I'm going to picture this interval between 3 and 12. Find our delta x. Remember, the width of each subinterval. 12 minus 3 divided by 4. So 12 minus 3 divided by 4. Of course, as ugly as possible. 9/4. They couldn't find anything nicer. That's okay. Okay, I'm going to split it in 4 subintervals. I'm going to have to determine these values. So 3 plus 9/4 is this. 3 plus twice 9/4 is this. 3 plus 3 times 9/4 is this. Because this is 9/4, this is 9/4, this is 9/4, and this is 9/4. So we have to find these values. 3 plus 9/4 is 21/4. 21/4. Okay. Now I can just add 21/4 to 9/4 and I get 30/4. And then 39/4. And 39 plus 9/4 should give us this, right? So 39 plus 9 is 48. 48/4 is 12. Correct. Perfect. So now remember the area with the left 4. Base, we said left. Base times the height at 3 plus base times the height at 21/7 plus base times the height at 30/4 plus base times the height at 9/4. Please make sure you do not move on because we said the left. If we said the left, we only have these, not this. If you had said the right, you would have used this, 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 and this. Since we decided on left, 1, 2, 3, 4. Only 4. Okay, so since the width is the same, I'm going to keep it in front. F of 3 plus f of 21/4 plus f of 30/4 plus f of 39/4. All I have to do now, determine this plus this plus this plus this, and multiply by 9/4. And that will be our approximation of the area. I don't even know where the graph is. Whatever the graph is doing, I don't care. Base times height till the graph, which is f of 3, plus base times height till the graph, which is f of 21/4, plus base times height at 30/4, plus base times height at 39/4. So now how do I find this? So I'm sharing my screen. I think I still have time. Yes, 4 minutes. So I hope I can finish it in 4 minutes. So in y equals, of course, I will punch in the function. Of course, it's an ugly function. I shouldn't say ugly, but it's even difficult to, it takes time to plug it in, to punch it in. Okay, plus 0.28 x to the third, and minus 0.3 x squared, and plus 20. Good, so the second, and okay, and I plug in 3. I plug in 9/4. No, not 9/4, 21/4, sorry. 21/4. I plug in 30/4. And I plug in 39/4. Good. So I'm going to use 4 decimal digits. And I'm going to write 9/4. And then I have 23.24. And then 37.0543. And then I have 57.9688. And the last one, 70.2643. Okay, then I have 9/4. Careful, it has to be in parentheses. 9/4 in front, and then open parentheses, and I have 23.24 plus 37.0543 plus 57.9688. 0.9688, and the last one plus 70, 0.2643. Don't forget to close the parenthesis, and I get 424.1867. So that's how we estimate the area under this graph. If this is the profit, rate of change of the profit, not the profit. If this is the rate of change of the profit, the area under the graph between 3 months and 12 months, or 3 years and 12 years, is 424, I don't know, million, billion in profit. That's what the area under the graph represents. If this is the rate of change of cost with respect to time, then this will be the total cost between 3 and 12 months, years, whatever. Whatever the function is, the total area under that graph will be whatever happens, total cost or total profit or total revenue, but that has to be the rate of change. I'm not going to continue, I'm going to stop, I promise, but I just wanted to show in the book, where is my book? Right here. So in the applications, we are just reading this, we are not going to do anything. A concert promoter sells X tickets and has a marginal profit. So this is the marginal profit. Finding the area under this graph will give us the total profit from the sale of whatever, between 75 and 300, this is the interval between 75 and 300. And this is what we had in our example, between 3 and 12.